That the name's Curlsgetsthegirls. I was like, sorry, it's a little unprofessional. Oh, it's already started.
Derek Manswell. Facebook Live.
Facebook?
Or YouTube Live. It looks a little weird though. Alright, Chetta, zoom in on the... Are you moving it?
No. Is it moving?
Oh no, it was just your shadow, sorry. It looked like you were
Well, it makes sense if I say that there is a force transmitted by a convenient of 106 feet per pound. Like the final force feet per pound. I don't know if that's force.
Ah, dang it.
That doesn't make sense. I'm not gonna say, but if they ask me the definition of force and all that, they ask me, okay, how much is it? I say, creates a force of 106.
Troy, we got any like little extension cord down there? But like a short one, so there's not like a massive cord here. Yeah.
That's how close to that's good.
Yeah, the one thing I didn't think about is if you could still fit in with the mount there. It did, so fair. But that's only when you can fit out easily. Yeah. You better not have to take out the whole shot. Yeah, we do. Oh, you might have to take off the tire, I'm not sure. But that's also one of that anyway. Yeah, we're gonna to get this, but we're gonna do the have the same diameter that it goes to this side. So we're gonna do one at this diameter and this
I do not see a brown box.
Oh, they're in that far bottom.
Oh, gotcha.
There's a blue key and there's two factors to tell her that. Probably ultimately later. I'm just gonna put things up. Yeah, they can, that's something good. That's easy.
Huh? Minute?
Probably like 30 seconds.
I mean,
I confused earlier.
oh, fair. I mean, that probably is just how YouTube is. It's not that big. you think you'll be able to see all of us right now?
What? What's up? I just want to see.
Well, not in front of the projector. Yeah, right there.
You see him in the projector.
Wait, let me see.
I think we will all. You're not going to be seen, bro.
Do I need to move it that way a tiny bit?
It's kind of hard. Yeah.
Or I can move it back a little bit.
Or like you said, we can just walk in and out.
Well, we still want everybody to be in the whole time.
Probably move it back.
I can move it back. How's that?
There's already one light.
Huh? I got lots of family, bro. Well, there's somebody named Simba Boy, which I don't even know who that is. Bro, people that used to follow my YouTube might be on it. Who knows?
It's looking kind of hard to see though. You're gonna be like basically out of it. Maybe put it almost by that second table.
Can you see like that stuff?
See like the.
You see what? This? Yeah, there's no way to avoid that. Alright, how's that?
That's probably as good as you're gonna get.
Okay. We ball. Wait, can I see it? I think that's good. That's not bad, actually. Somebody freaking knocks that down. What are you seeing? Any Trinity people in the chat? Did you hear me say Trinity? I said, are you seeing any Trinity people in the chat though? I put my face in front of it too. Any Trini in the chat though? I gotta go pick up the check. I'll be back.
Go. Throw your belt. I mean, it's gonna be weak. Bro, it looks so nice. ¿Y si le pongo aquí esto? The what? ¿Has visto nuestro póster, güey? Está muy guapo. Ah, para las fotos. Ah, ese es. Ahí pone. Flyer. Pero yo creo que son.
Yeah, they need that.
Sería, ¿no? Después entonces tenemos que quedarnos aquí, ¿o qué? Para eso.
Creo que sí. No sé cuánto.
Bueno, yo no. Bueno, no, porque. Como así.
Right? Yes.
Oh. Al Real de Madrid. Perder otra vez.
Yeah, and there's gonna be more that are pure white, which is fine. Yeah. Good in the fall, we're gonna show. I so love it better when there's actual property to show. Project to show.
Texture, I'm gonna tell the employees that your tip set is clear of the
Jared up there?
No, I think he went back home. He has to bring back food.
Oh, okay. I'm trying to figure out where to put his stuff. I'm just gonna put it right here so it's not on the table.
Alright, yeah, I'll let him.
No, this one's more than black.
That looks good. Woo, you look good.
yourself underneath. Just try to clean out.
Yeah.
How you doing, Jackie? Good. Your husband ready for this to be done, hopefully? Okay. I'm sure.
I think so.
Jackie wants to sit next there.
Huh?
Jackie wants to sit next there.
Alright, so you guys want to have separate photos? Woo-hoo!
Everything working out? You checking stuff?
Yeah, here's the one that.
One more thing in the water. People go outside, so it's not in the water. Because I think that's what I think the water is.
That's good? You sharp?
Huh? Yeah, but it's going on the drain of the good one.
You do?
That's fair.
And it's like, some people,
Yeah, we're good. Thanks, Darren. Doesn't work? Yeah. Passionate about it. You're the experts, right? Oh, did you guys work with the, did you guys try and focus this or anything?
See what happens?
You can only get so good at this one.
I feel like they don't move when they're under your hand.
Where's the?
Is that everyone in our work? Is everybody?
Yeah, it's flat.
Sorry, what?
It's flat, right? So, yeah. Go ahead.
Everyone from 102? We move when we stay next to
The next to the screen, yeah.
Already?
Oh, frick. Actually, sometimes.
No, en verdad no, tampoco. Claro que ¿te imaginas, verdad?
Also, whoever's handing out my stuff, hand me like, get one on each side. No, I'm just showing. So all of that one, like I'll show you.
Oh.
Well, isn't that fine? I can't put it upright, otherwise we can't see everybody. Yeah, just leave it out when I start talking about it. When I start on the slide. Like the one with the picture of the transfer case, then you can.
Looking dapper.
Don't knock my phone, please.
Is it recording?
It's a laugh.
Oh. I should be the what?
Be the guardian.
Actually, wait, no, I do.
So is that also here? Or is that behind it?
Can I borrow
Use my pencil. Yeah.
on campus. It was like super specific. It was like, do not sign another student. Yeah, but then they don't want you to sign. That's the only one I brought. It's kind of raw.
All right, listen up. Listen up. There, we have some attendance sheets. One's for Interim 107 and what's the other one for? 102. 102. Johnson get credit for this somehow, some way. You better make sure you find this clipboard and put your name on it. So we'll pass it around. We'll be moving around.
Yeah, come on in. There's a sheet going around. During 102 attendance and during 107. Sign yourself in. Do not sign somebody else in, right? That would be an academic integrity violation. We don't want to go there.
I think you can before this, yes.
Wait a minute, right?
I think that's important. I'm not sure. I'll try to submit it anyway.
Yeah, I mean, I already have like the most amount of points basically.
Because I'm sure there's some good uses for PD, but I guess you can just ask them.
What a fun day. It's a beautiful day. From the team.
Once again, make sure you have to have attendance credit. Find that clipboard.
That would be smart.
Maybe we'll just start the recording now. We just start yet.
Pass the clipboard back because amongst the crowd here. You need to put your name on it.
Well, I switched the couch right here. We got a couple minutes. Come in. There's still some good seats down front. There's more chairs in the back. Now, where's our attendance sheet floating around there? All right.
Hey, Emil and Bryce, you guys should look at this rubric. I'm started thinking about this for your senior design project.
Yeah, I would totally make it word for word of what I
I don't know. I mean, you can see there's some posters down here, but those look like all the final projects. So I'm guessing they're not set up there.
Once again, if you're in Interim 107 or you're 102, find that
So
clipboard.
where's that keyboard going around right now? Good. Got it. So there's two sheets. There's engineering 102, initial on that one, engineering, supposed to be in engineering 107 right now. Supposed to be here right now. Write your name in there. Again, sign yourself in, sign somebody else in for that. Well, let's get started here. What a beautiful day. What a great day. Another, we'll resume our engineering design showcase. 7th annual engineering design showcase. So we've had some excellent presentations so far, and looking forward to this one. This is our SDE Baja design team. Some of you have been involved in that, sort of supporting them. And you know, for a bunch of guys that work in the shop all the time, they clean up pretty well, don't they? Look at all this tech here. So yeah, they're going to talk, and there'll be plenty of time for question and answers. Take your notes in there. And again, if you're in 102 or 107, make sure before you leave, you've caught that sign-in sheet and get credit for attendance for a day here. Any faculty members, I think everybody's got some rubrics to evaluate that front and back. Ooh, you got it failed. Hey, can I pray for us and for the team here, and then we'll hand it over to them. Father, thank you for this beautiful day and the opportunities that you continue to give to us. Thank you that in this broken and fallen world, you have called us in to be a part of reshaping that and to try and accomplish your purposes and your kingdom would come here. We pray that we would know your presence and your guidance at this time among all of us listening, but especially among those that are talking here. Thank you for all the gifts that you have put into them throughout this work here, for keeping them safe and for guiding their work. We pray right now they would know your presence. They would work in their heart and their mind and through their mouths, and what they speak may give honor and glory to what they've done, but especially glory and honor to what you have done in and through them here. So we ask this all in the strong and heavenly name of Jesus Christ. Amen. Take it away, boys. Oh. What? I said I was going to start the recording, and I didn't. Right now. Is it on? Yeah. Is your mouse thing on? I'll try. What's going on? Good? All right. Thanks. Thanks for your patience.
Hello everyone, welcome in. We are the ONU Tiger Racing team for the Baja SA competition, and we are here to present one final review of our design as we close out the school year. I'm David Perez.
I'm Jarek Manswell.
And Andres Viedma.
So we want to acknowledge a few really significant people that we've worked with and that have helped us throughout this project. One of them being Troy Lavelle, who is our lab manager and has helped us with fabrication and purchasing several different things. We also want to thank the Baja Club members, and more specifically Ashlyn, Owen, Ethan, and Andrea. We also want to thank our chassis welder, as well as our knuckle welder, Grant Wheeler. And then last but definitely not least, we want to thank Dr. Schroeder for being our faculty mentor throughout this. We also want to explain our responsibilities. We've split this up into subsystems throughout our team. I am in charge of the team, as well as drivetrain, frame, as well as SAE requirements. David is in charge of suspension and electrical. Juan is in charge of brakes and budget, and then Andreas is in charge of steering.
So now to give some background about the event, the goal is to build, design, and test a four-wheel drive off-road vehicle to breed innovation. It's an event with over 100 different institutions, both in the US and worldwide. And before you can compete, you have to pass a thorough tech inspection just to make sure that your safety is in order and that you're in compliance with the rules. And after that, you can face off in different events. So there are static events where the car just kind of sits there and it gets judged. And then there are dynamic events such as hill climb, acceleration tests, and things like that, where the car is actually being driven and it's facing off against others. And then the final event, which is kind of the capstone event, is a 4-hour endurance race where every car is on the track at once, and you are competing to see who can complete the most laps in that given time period.
Well, so as mentioned, we're going to participate on the SAE Baja race. This is a collaboration with the Baja Club. Our goal is to design and fabricate a vehicle for this competition. We need to design the roll cage, drivetrain, suspension, steering, and brake system. Not only that, but we also need to provide specific documents of everything we do through this process. We need to provide documentation for competition, as well as following the rules that are necessary to compete in the SAE Baja rulebook. Our number one priority is to keep the driver safe when in the race. So we focus our design on keeping this safety for the driver and use professional engineering, meaning like having everything documented, as I said before, with common sense and through true methods of what we do so far in our project.
So we had a lot of issues with last year's car. one of those main things being poor suspension geometry. So because of the way that it was designed, we weren't able to adjust camber and toe-in separately. They had to be adjusted together, so once you adjusted one, the other one would automatically be adjusted. So we had really stiff suspension because of that. We also had really overbuilt suspension, front and rear. So it was really just heavier than we needed it to be, and FEA was not performed on it, so it wasn't really sure what was necessary of those components. This poor steering geometry was also a big issue. With steering, we had a lot of issues being able to turn the steering wheel, and even with power steering implemented in the car, it was still very difficult to turn the steering wheel. And then also excessive weight, which is one of our biggest issues. The car weighed about 866 pounds, comparable to the lightest car at competition, which is about 360 pounds. So we had a really big issue with that. We also had to add members at competition last minute due to failing requirements where we needed members on our frame to keep the driver safe. And then the cockpit was also not ergonomic. We had a lot of issues with the driver being able to press the brake pedal. They weren't able to get their foot fully extended, so it was very difficult to get a lot of force on the brake pedal. And then because of that, we failed brake check at competition and were not able to compete.
So with those issues from last year in mind, we created a set of functional requirements to guide us on our design this year. So first and foremost, with safety as our #1 priority, we want to make sure that the vehicle can sustain dynamic loads. So that goes for all the subsystems. We want that force going into the car and not jostling around the driver. We want to be able to lock all 4 wheels during our brake check, because that's bitten us a couple times already. We need to be able to traverse uneven terrain, keeping stability, and again, keeping that driver safe from any movement. And we need to power all 4 wheels because, again, the competition requires 4-wheel drive, so if you don't do that, you will get a penalty. And then, again, we need to comply with the Baja SAE rulebook for 2025.
Well, as mentioned before, safety is our #1 priority. So this was our main objectives for this year, to keep the driver safe. Reducing weight in every subsystem was always our concern, to be able to pass brake check in the competition. This is also gonna make our vehicle quicker, more agile, so we're gonna probably do better in the race. And of course, it has to withstand all the forces, all the obstacles in the race, so this vehicle has to be durable, comfortable for the driver, as it's for our race, so it has to be comfortable for the person who is going to be in it, and affordable to keep it within our budget that we have for this project.
So we had a set of design constraints that were limiting our design as we were going about creating it. As Andres just mentioned, the budget was one of the things that was constraining us. So we had to properly decide where to spend our time and money. And then there's only one approved engine, which is a Kohler engine, and that's the only engine that any team can use. Additionally, we are limited to the maximum width of 64 inches, so we can't go above that. That affects our ball joints and our control arm lengths and things of that nature. And then egress is also a limiting factor because it affects how we can package our components. So every driver has to be able to exit the vehicle within 5 seconds. So that affects how we design our frame and where we put certain components. And then safety gear goes hand in hand with that. We need to have our wrist straps and our fire extinguisher. So again, that limits our packaging and our placement. And again, we need to adhere to that Baja SAE rulebook for the 2025 season. We have to follow all those rules so that we don't get penalized.
So the frame is the building block of our whole vehicle. So as you can imagine, it really is important how we make that frame. And so the goal realistically was to start off with creating a lightweight and durable frame while we're still adhering to that rulebook. And then we wanted to improve the center of mass because the previous year's car was really high, so it had a lot of issues with turning, and it felt like it wanted to roll over. We also want to maintain the budget that is fairly low, and then we also want to design this frame for simple repair so that we can remove other components, and we don't have an issue with fixing things at competition if necessary. And then these are the iterative design methods that we used throughout the process. We started with that one on the left, and then we moved over to this middle one, and then finished with this right one. So one of the things that we want to change from this year is the pedal placement. So we want to put the pedals on the top of the front of the chassis instead of the bottom where we had put it last year to allow the driver to be able to extend their foot further distance. And as I previously said, this is the final design of the frame, and so we had to move the members here further into the frame so that we could attach the rear suspension arms straight to that point, and we shortened this simply to reduce weight. We use 4130 chromoly tube, and that has a cross-sectional area of 0.1336 inches squared, and we calculated the yield strength of that to be 3,743 psi. In terms of our frame fabrication, as I had previously said, we used 4130 chromoly tube, and we were able to notch, grind, and weld all of those components, and creating a far less heavy frame than we anticipated, and we were able to shed about 70 pounds compared to the previous 220-pound frame. Our frame weighs about 150 pounds. We'll also be able to fulfill the requirements of the rulebook and keep our frame ergonomic for the endurance event.
So these were our objectives as we set about designing our suspension. First and foremost, we wanted to create a smooth handling vehicle to be able to traverse that rough terrain and again not bounce around that driver. We wanted to minimize track scrub so that we're not losing traction as we go over obstacles. We needed it to be easy to repair and maintain so that we're not losing time while others are racing. And again, we have to stay under 64 inches of width, so that affects our ball joint angles. And then our functional requirements, we wanted it to articulate 12 inches so that we can traverse over obstacles and not have to stop. And then we wanted to achieve 14 inches of ground clearance in a similar vein so that we can drive over obstacles. So these are some of our design alternatives that we set about creating. Initially, we were thinking about, we were considering either using off-the-shelf knuckles from some other UTV or ATV, or getting CNC aluminum milled knuckles. And finally, we decided on fabricating steel knuckles because it was a good balance of affordability, strength, and additionally, it gave us the design freedom to adjust our mounting points for our subsystems wherever we need them. And then for the shocks, initially we considered reusing our old Fox emulsion shocks and just replacing the springs on those. But we ended up choosing Fox 2.0 remote reservoir shocks with new springs right from the jump so that we could get them tuned and we could adjust our dampening and rebound independently. And then for the front, we had to go through a few different iterations because once we actually fabricated the arms, we saw that they didn't necessarily fit together with the other subsystems quite how we had planned. So we had to go back and change a few things, but we ended up with our design of a dual wishbone suspension with a loaded lower arm and a top arm that just controls the camber and the caster. So then for our rear setup, we had these different design alternatives: dual wishbone, McPherson strut, trailing arm, and then swing arm. We ended up picking the trailing arm design because of its superior usable travel and control over geometry, even though it's a little bit heavier than the McPherson strut design and the swing arm design. But overall, it was just superior in the other categories. So then for analysis, we really designed our tubing based upon a drop test. So we wanted the car to be able to survive a 5-foot drop test, even though that's not necessarily an obstacle that you will often encounter. But it does happen where you miss a jump or something like that, and you slide off the track, and you have to be able to survive a jump like that. So we ended up calculating our maximum load for that, and using a 1018 steel rating, we found that the minimum moment of inertia that we could use with a 1.25 factor of safety is 0.277 inches to the fourth. So we selected our tubing based upon that. So we ended up using a 7/8 inch 1018 tubing with an 1/8 inch wall, and that had a inertia rating that had a moment of inertia of 2.89 inches to the fourth. So at that critical point, we have a higher factor of safety. And then we used SolidWorks simulation after we designed the arms to make sure that they would actually perform in the way that we wanted them to. And then we measured the different ball joint angles on the car, as well as the travel overall and the alignment geometry. So that was just to make sure that we're not binding the ball joints wherever we can't, so that we're not breaking them when we don't need to. So then this was the final design, as I mentioned earlier: dual wishbone with a loaded lower arm and a lightweight upper arm. And then we have a raised rear trailing arm with 2 radius rods to control the track width. And then we chose a spring rate of 100 pound-inch. Initially, we had calculated the spring rates to be a little bit lower, but once we talked to the people that sold us the shocks, they recommended to just use 100 pound-inches for the spring rate, and then just adjust our preload based off of that because we could tune our shocks to work better with that spring rate.
Okay, so for rate, you have some times in front of your curve. we did not pass the brake check from last year competition, and also the pedal was not comfortable to push. So we have some balls in altitude, like locking all the four wheels, so we can pass the brake check at the competition. Also the position of the brake pedal and implementation of the inboard brakes. So for that we have some codes and standards for the rule. First, the system needs to be hydraulic, single pedal operated, and acting on all wheels. Also, as I said before, we must lock all the four wheels. We require two independent circuits. That is like connected like to the pad, the brake pedal. We need two master cylinders. One is going to actuate on the rear brakes and the other one on the front brakes. Also, for the pedal, we need a minimum force capacity of 2,000 newtons, and the brake light must be activated by hydraulic pressure switching. That means that it needs to be connected to the brake lines. And as I said before too, the testing, we must pass the dynamic brake check. So for that, we did an evaluation and selection process for the inboard brakes versus the outboard brakes. First, we have some advantages for the inboard brakes that we need less strong mass. That means that better suspension response. Also, protected from mud, water, and dust. We have just one disadvantage. It was like complex traction integration into the brake. So for that, we have the piece that you guys can see. Design it like with the joint. It's gonna be connected to the drivetrain. One part is gonna be connected to the drivetrain, and the other part is gonna be connected to the axle. As you can see, it's the rotor, and it's connected to a little piece that is gonna be welded to the CV joint. Also for that, we're going to use a caliber with 120 diameter and a bigger rear rotor compared to the front. For that, we want to look for a bigger rotor for that compared to the ones that we have for the front part that we used last year too. So we can see the piston area is much bigger, like, and the weight is lighter if we choose two of them. Also, the diagram is bigger, so that means that we will have more brake force. Also, if we need performance, would be better because we said we will have more surface area. But we just have the main problem. They won't let you. We will have to pay on brake force. Also, for complete the force required to lock the wheels by doing hydraulic dynamic operation. And with the help of Dr. Weber, we're actually using by doing like free-body diagram, this formula. Also, we like for the front calipers, the PS1s, small ones, and we require a force of 5,000 newtons to stop the car. And for the big rotor, the Dynapro, we need a force of 7,000. Also for the pedal positioning, we're gonna put it higher and more comfortable for the driver. And for the brake line, last year were too long. This year we're gonna, instead of the long one, instead of being 10 feet, it's gonna be 6.50. Also, we're using one of those lines to the inboard brakes, and we're gonna have less probability of failure due to the less spin components in the brake.
Well, steering was always an issue, even though the functional requirements are not a lot in the rulebook. There are a few. This system is required to be mechanically operated, meaning it cannot have any type of like electrical help when operating the system. It has to be safe and ergonomic, so it has to work along with the frame to give the driver enough space when you are in the race and being comfortable for the driver. And finally, it is also required to perform a minimum of 1 full rotation when steering the wheel. Our objectives were first to reduce weight, as this was one of our main concerns with the whole project and the whole car. We got rid of some parts in this subsystem, especially power steering, which I will go more in depth in a few minutes. But also reducing the amount of gear joints that we're going to use for the steering shaft design. That overall is going to reduce the weight of the system around 5 pounds. Then we focus on having an efficient turning. This is basically thanks to geometry. It's all about geometry in this subsystem. So having the rack and pinion position where it should be and having a proper angle is really important for this system. And finally, we wanted to reduce our expenses. So we are going to reuse some parts, especially the rack and pinion, which is probably the most expensive part in this subsystem, and we're going to reuse the one from last year so we can save some money in there. This system has a steering wheel that is connected to a steering shaft, and along with the U-joints, it's going to translate this rotational motion into a rack and pinion that is then translating into through the tie rods and connected to the steering knuckle. It's going to translate translational motion into the wheels. That's going to move the wheels from left to right. That's our main goal in this car. Then for our evaluation process, we first studied our last year car, and we were able to actually test it. So we realized which parts were more, they had more room to improve. So we redesigned our system and we went into fabricating. Through all this process, I focused more on these three calculations. You guys can see the Ackerman angle. This is also about geometry. This is gonna reduce the amount of movement on the wheels when you're turning. You know, slippery wheels to the sides. So that's gonna be really important when in the race. So the front wheels are not moving one to the right and the other one is moving to the left. So both are coordinated. And thanks to this geometry, each wheel is gonna rotate around its own pivot, so around its own circle. And that's going to help for a better efficient turning. Then our turning radius is going to be reduced. As last year, to complete a full rotation of the whole car took us way too long, so this year we wanted to reduce that turning radius. And finally, the scrap radius is the radius that is formed between the axis of the center of the wheel and the axis with the steering axle. And that is really important also with suspension. I work along with David in this because having a really big scrap radius is going to produce misalignment in the suspension and the steering system. So when we're in the race and we're going through all these obstacles, the car can be damaged and the suspension and the steering can be affected. These are some of the calculations that I performed, and then thanks to this geometry, we reached and we set up our turning radius to be 11.5 feet. Our scrap radius is set to be 1 inch. Our Ackerman geometry is said to be 100% when the turning radius is 11.5 feet. Well, we were able, as I said before, to test last year's car. We were able to perform a sign driving test at the beginning of last semester, and we realized the amount of force that was required to actually steer the car was too big, and that our turning radius was excessive. So we wanted to reduce this. And for that, we designed another system on SolidWorks where we focus on creating a better geometry of with all the parts and having a rack and pinion better position, having a better steering shaft angle, and we also perform FEA on the tie rods because those are the parts that are going to be supporting all the forces. So we perform some FEA to see and check that these parts are going to be able to stand all the forces during the race. Finally, we got rid of the power steering for this year, as this was creating excessive weight and it wasn't being efficient and it wasn't giving us enough turning potential or turning power. So we got rid of this element. We also lowered the rack and pinion, and we're going to have it positioned in front of the differential. It's also important to take into account all these elements, so this is not interfering with other elements of the car. But rack and pinion is going to be positioned in front of the differential, which is already mounted, and that's going to create more horizontal line with the steering knuckle and an efficient turning and better transmission of the force. We also reduce the number of U-joints on the steering shaft to reduce weight and to make this force transmission more efficient. As well as reducing the shaft angle, And as I said before, our turning radius is gonna be 11.5 and our scrap radius is gonna be 1 inch.
So following up from that, the drivetrain is the power of the vehicle, of course. And so, as David previously said, the engine is a 14 horsepower Kohler engine, but a restrictor plate is put on that, so it is tuned down to 10 horsepower. And this is the engine mount we used. We made it a sliding engine mount simply for the ability to tension or slacken the belt based on sliding that engine away or towards the secondary pulley. We chose a CV Tech CVT because it gives us a great large ratio change that allows us for a really good acceleration as well as a really good max speed. And our efficiency is 85% on that, which is very parallel to several of the other competitors that are at competition. So with the drivetrain, the design goals were fairly simple, but very important. So one of those being compact and lightweight. We want this drivetrain to not be in the way of the driver, especially that front diff and that prop shaft that goes underneath the seat. We also wanted it to be high strength for the off-road high torque application. And so I made the transfer case as well as other components a factor safety of 3. And to do this, we used optimal materials like aluminum for the casing of the transfer case that allows it to be light, but also 4130 and 4340 for some of the internals of the transfer case. And then also we want it to be serviceable. We don't want to have issues at competition where we can't fix something or can't replace something. So we do have extra parts of the critical weak points in the drivetrain. So we had some design alternatives with the drive as well as the four-wheel drive transmission. So with the CVT, we chose CVT simply because we get a lot more efficiency than belt drive, not as much as chain drive, but for the durability, the CVT is a lot stronger, it lasts a lot longer, and we'll be able to use that for years to come. And then it is also a lot easier to maintain. We can also change things like the weights and the springs in the CVT a lot easier than we can change things in a belt drive or a chain drive. And then one of the other really important things was also weight, because something like a chain drive is a lot heavier. And then for the four-wheel drive transmission, we picked a transfer case, a custom transfer case, rather than an off-the-shelf transmission, simply because of the efficiency being way higher with the transfer case. With an off-the-shelf transmission, you get a lot of percentage loss because each set of gears you lose about 5% of efficiency. And then also, again, ease of maintenance is a lot easier on something that we custom built and we know how it works, as well as the weight was far lighter. So some of the calculations I did was to figure out that acceleration and the max speed. So to figure out the acceleration, we based it off of hoping for a top 5 placement at competition. And to achieve this, we need to go 0 to 100 feet in 4.7 seconds. And using a distance equation, we're able to solve the acceleration to be 9.0 meters per second squared. And then based on that, we need a gear ratio of 7.31 to achieve that acceleration. With that acceleration, we get a max speed of about 28 miles per hour. Simply taking the rotational speed, I can turn that into linear speed and then convert that to miles per hour. And then this last calculation on the bottom is multiplying the efficiency loss times the actual speed. So we get 28 miles as our max speed. So the purpose of and function of the transfer case, as shown in the picture on the bottom, essentially drives the car. It puts power to the rear wheels as well as the front. In our scenario, we kind of eliminate that drive shaft, and our axles, or rear axles, come straight out of the transfer case itself, while that part on top extends power to the front wheels and to that front diff. As I said before, it is a custom designed and built transfer case, and it's very lightweight, so in total it weighs about 23 pounds, including the internals and the casing. And we have made it out of aluminum, all bolts are steel, and then we have also purchased bearings, but have not yet been able to put that together. And then the other important thing is this was fairly inexpensive, or initially started, so it was. So with the transfer case validation, I used FEA as well as MATLAB and SolidWorks to conduct several different things. So first with FEA, we conducted force tests on and torque tests on the gears themselves, as well as the casing, and then I use MATLAB and SolidWorks to test the gear stress and gear ratio analysis to make sure that all of those would line up in the way that we wanted them to. We will also do a bench test with the CVT and the transfer case to be able to make sure that these two run in parallel and run well. And the results from that is that we get minimal deformation under max torque, and we don't get any binding or misalignment issues during testing, just with rotating 3D printed parts and such. And the material that we use for the internals, as I might have mentioned before, is 4130 steel for some and 4340 for some of the others. And the yield strength of that is 750 megapascals, which puts us well below or well above, our factor of safety, which is 3, and gives us about a factor of safety of 4. And then the transfer case, the casing of that whole part was made of 6061 T6 aluminum.
So for budget, first we create an Excel sheet so we can calculate all the items that we buy, so we can have the total balance in the right moment if we're gonna purchase something new. So for sponsors and donations, we received this year a total of $16,000, and for expenses, we spent around $13,000. Now we have a total balance of $3,000 that we want to make some changes. Here, as you can see, that's how we organize everything. We put the item, the name of the item, the price per unit, quantity, the tax, and the total price. So for every subsystem, we have a different sheet. So for savings, we have some savings for the rear calipers, and as Andres said before, for the racking pin. And our key investment were the transfer case, they cost $4,500, and the differential $2,000.
So we had some challenges throughout this year. One of those main things right now being the transfer case. The casing was on back order for a while, and so we were waiting for that to come in. And then the tariffs increasing the cost by 100%. As we have not gotten the internals of that, it's affecting us a lot negatively and making it difficult for us to continue to test and design to finish our vehicle. Custom designing and fabricating the knuckles, axles, and control arms was also a big feat. Using different methods to try and test different systems took a long time, and repeating that process did take a lot of time as well. We also had issues with reducing the weight significantly. Our goal was to reduce at least 300 pounds of weight compared to the previous year's vehicle. And as of right now, we are on track to do that, but that has been a difficult feat, getting rid of that weight in whatever areas we can find. Shopping efficiency has also been somewhat of a difficulty, being able to get access to some of the tools that might help us do things quicker and get that done in the best way possible. And then, as I previously said, redesigning the control arms took the majority of our time since we went through 3 different suspension designs throughout this process.
So now, we still have yet to complete a lot of our testing and validation. Some of that is due to some of the challenges we have faced, but these are our lists of things we are yet to complete. And some of them we have done. So for example, we have done the roll cage check. We have submitted our roll cage documentation package, and we have also physically checked it with our drivers, making sure that we have clearance and things of that nature. We have also measured our suspension travel, so we do have 12 inches without binding, so that is a pass there. We are yet to test our jump/drop test, our durability test. However, we have done our subsystem weights, and that is a pass. So for example, I was able to reduce about 28 pounds off of the suspension from last year, so I stayed under my goal of 70 pounds. And Jared was able to reduce his to under 35 pounds, which was the limit he had set. And still, we are yet to do our dynamic brake lock, that's to be determined, our acceleration test, our top speed, our turning radius, and our steering effort. But we hope that we will be able to do this in the next few weeks.
So we've also completed a lot of goals that we had set out for ourselves. One of those being the frame being completed. The suspension has also been completed, and we've got that front differential mounted. And we've done all this while continually staying under the budget. And then some of the important things with the Baja SE competition is that we've submitted all of the deliverables, like the roll cage documentation, the bill of materials, the cost reduction report, the business RFP, as well as our virtual presentation with them.
So now, as we alluded to earlier, our future goals, we still have to put our transfer case together once we receive our internals. We still have to mount our steering system, attach our body side panels. We still have to mount our pedals and our seats. And we still have to tune our CVT once we start our testing with it. But hopefully, we hope to finish all these things before we go to compete in June.
Well, in conclusion, we've been working in all of our subsystems, and as you guys can see, this was a journey of constantly testing and improving. We also worked on last year's design, and we went from there to see different ways on how to improve it. We were able to reduce weight, as David mentioned before, in all of our subsystems, so we accomplished one of our main goals. We also improved maneuverability, and that is going to help us to get a better top speed for our race and to have more efficient turnings and better suspension overall to perform better in our race and being able to compete against our adversaries. And last but not least, we were also able to involve a lot of students from this program, especially freshmen. They really helped us a lot through this journey, and this was also one of our goals, to create a project that is going to be there for next upcoming seniors, and that people is going to be able to look up to and to study and work on that. So that was also accomplished, and a huge thank you to everyone who was involved in this project and who helped us along the way.
Do you guys have any questions?
Most of us have been in a car, but maybe not one like this, so maybe some questions about that and the design process. Also, just a quick check, the sign-in sheet for 102 and 107, is that still moving around? And some people came in late. Where'd that end up? Back there. So if you're in 102 or 107, make sure you catch that for you. So, who's got a question for the team?
I got a question. So you mentioned that you made the motor mount able to slide. What was the advantage to being able to slide back and forth?
So simply, the engine being able to slide allows us, so the transfer case is mounted fixed and can't be moved. And so when we make that engine mount sliding, it allows us to, the engine shaft goes into this part of the CVT, which is the primary pulley, and then the secondary pulley, which goes onto the transfer case. And so when you slide the engine away from the secondary pulley, then the belt gets tighter, which allows us to get better efficiency and better acceleration.
£300 is a lot of weight that you were able to do. It's like, where have you been able to reduce the weight the most? Where has it been like bits and pieces?
Yeah, it has been bits and pieces. Like I said at the beginning, a lot of it was the frame. So just the frame, we got rid of about 70 pounds. And then with the drivetrain, that was the biggest part. I think I got rid of about 120 pounds. Just with how they use the rear diff as well as a transmission, added a lot of weight compared to just the transfer case.
Did you have some trade-offs? Any sacrifices you had to do in order to accomplish that?
We did lose a little bit of strength in certain areas. We also lost reverse, so we did lose that. But in general, it hasn't been a huge compromise for what the competition is meant to do.
Okay.
Yeah. For those of you who don't know, you actually aren't allowed to reverse in the endurance event itself. You will get red flagged and kicked out because it's unsafe. The only time you can use reverse is in one of the events, one of the dynamic events, which is maneuverability. So that wouldn't be very necessary for us to have reverse.
Can I ask some questions? Number one, the engine mount.
Yes.
Did you consider what happens when this thing is jostling around?
That it would move? Yeah. Yes. So when I was younger, I actually built my own go-kart when I was about 16. So basically we will be welding something like a nut with a bolt that that can be tightened against the block of the engine and keep it from moving. Because yes, it will slacken on its own.
Very good, wonderful. The brake force, I thought I saw two different numbers there. One was like a 5,000 something.
Yeah.
Okay, so we had, the brake force
Yeah.
required there 5,000.
5,000. That one is the force required to lock the wheel by one caliper, the PS1. It's more
Right.
They're going to the,
A couple of slides earlier, there was another, like a goal of brake force. What was that? Okay, so pedal design minimum 2,000.
yeah. So, okay, that's the force, that is the total.
Okay, what?
The total, like, plus the two front calipers and the rear caliper.
Yeah, so the rulebook actually requires us to be able to put 450 pound-foot force on the pedal itself. That doesn't necessarily have to do with how much force you need to lock the wheels.
Right.
It just means that you have to be able to put that much force on the pedal itself.
And what was the 5,000?
Like the force, like the PS1, the caliper, is gonna make to stop to lock the wheel.
This is the force, this is not the brake pedal force.
No.
No, okay.
No.
That's the force of the pistons in the caliper itself.
Yeah, okay, that's
But-
what I was confused about. Okay.
This is what you would achieve from the PS1, which you are using the front, is that
Yeah.
correct? But you use a different one in the back.
And from the back is like 11,700.
Is that per wheel?
Yeah.
Or total of
caliper,
two
yeah.
wheels? Okay.
And then the last thing I have, all right, being the statics mechanics off around here. When you designed your frame, and you looked at the forces necessary to bend it, break it, whatever, did you consider something very important in repetitive banging and jerking? Remember the term? It's a quiz.
I'm not sure I do.
Remember the term? Perhaps repetitive loading?
Fatigue?
Yeah!
Oh, okay.
Did you? Yeah.
Yes, we did. And so our frame was somewhat designed off of last year's chassis, with the attempt to make it stronger but also lighter. I know that they did FEA on their frame, and so based on the FEA that they did, we only increased certain members. We didn't decrease anything. We did remove some of the members that they added additionally after, but that wasn't something that they had put in their FEA initially.
Okay, all right. So the answer is regressive fatigue.
Yeah.
Very good. That's all I have. Okay. Thanks, guys.
Other questions about the
Yep.
design process? Go ahead.
What is the expected timeline for you guys to get this done?
Yeah, so a lot of that is really dependent. So I talked about tariffs earlier. So our internals for the transfer case, as well as the transfer case itself, are ordered from China, from a manufacturing company. And we ordered them before the tariff issue happened. And so now we are waiting for them to send those things. But those also pose a significant financial issue because of the tariffs being so high. So we are really waiting on that. So we plan to do all of our mounting with the transfer case with 3D printed models, so that as soon as the parts do get here, we can just put it together and be able to start testing it right away.
So you said that last competition, the brake check was what got you. So is it the pedal placement? You said that the drivers weren't able to get to it properly?
Yeah, so that was a big part of it, as well as the rotational mass was really significant. So they had some steel plates that were used to space out their hubs, and so that added a lot of rotational mass that makes it harder to brake and lock those wheels, as well as the overall vehicle being 866 pounds. But also, the pedal was so close to the driver that the driver's leg was like almost fully bent, so you can't get as much force when your leg's really cramped up.
So how quickly does it have to then lock up the wheels then to be able to pass the brake check?
So you get an acceleration from 0 to 100 feet, and then after that, you have cones, and then you have 10 feet after that your wheels have to lock up in between.
Okay.
Yeah. Dr. Dr. Weber, you had a question?
Yeah, I was just curious about the power steering. You guys said that you got rid of the power steering. Could you just explain? I know like part of it was kind of a weight thing, but what do you end up losing? Like where might that affect your ability to control the car? If it's rough terrain or something like that, or weather, or what type of sacrifices are you giving up for doing that?
Well, actually, main concern was the weight and what we actually gained from having the power steering in the car. We tested it, like I said, and they also went to competition last year, and it wasn't beneficial at all. It wasn't producing any better gear ratio or anything for the vacuum pinion, so it wasn't being translated into the motion of the system. So basically, we analyze it, and with proper geometry and proper ratios, we are gonna get a better steering turning. We don't need to have it there, so it's gonna reduce some budget, and it's gonna reduce weight. Was mostly.
So it shouldn't be any more difficult for the driver to turn?
Yeah, so one of the issues with last year's car was the steering geometry itself. So the rack and pinion was really high compared to where the mounting points on the knuckles themselves were. So instead of force going to the side, to both sides, we actually had a lot of force going into the ground, so that's what also made it a lot more difficult. As well as our scrub radius was about 4 or 5 inches compared to what we planned to be an inch. And scrub radius makes it a lot more difficult to turn if it's a lot larger.
Why don't you define scrub ratios for those who don't know? In layman's terms, there you go.
Scrub radius is
the radius that is formed, is the axle of the wheel, so the center line of the wheel, and then the steering axle. So they form like an angle. So the radius that is formed in between those two lines, that's the scrub radius. Like I said, that's important because when you are like in the race and you're jumping and you're like going through obstacles, that's going to create misalignment if the radius is too big. So it's kind of a concern for the steering system too.
Thank you, very good.
What's the maximum height for the driver? Because I think I've heard that they cannot drive the car because he cannot fit on the car. So is there any restrictions for the driver to be on the car?
Yeah, so one of the restrictions is when your helmet is on and you're in the seat, the top of your helmet has to be at least 6 inches from the from the bottom of that roll cage, bottom of the top part of the roll cage. And so basically, if you're tall enough, at least if the top part of your body is tall enough that you go too close to the top of the frame, then you can't drive. I designed it specifically so that, not because I didn't want to drive, but because I wanted to make it as lightweight as possible and as simple as possible. So I made it for the second tallest person on our team, which would be like Juan or Andreas or Ashlyn.
You mentioned something earlier about last year's car, because I remember last year we had a problem with towing in the chamfer, and you mentioned that you like separated those somehow. How did you do that?
So, the way we did that, and it's actually not fully shown here, but that knuckle can pivot around the trailing arm, and it's going to have another tie rod to control the toe in. So you can adjust those 2 radius rods to get the track width and the camber curve that you want, while still being able to adjust the toe in and out separately.
Okay.
You can see it on the card down there later. If you want to see it.
One more question, maybe?
Well,
Go ahead, Joe.
that'll be good. Lot to do this year. What's the biggest lesson, your takeaway, that you've grown or learned doing this project from each of you?
For me, I think all the things that I learned with David and Derek, like all the nights putting on the shop, putting material.
Oh, fabrication skills.
Yeah.
Okay.
Well, the importance of designing, testing, and calculating everything before actually building. As engineers, I think keeping it within a budget and time constraint, so having that realistic project, I think it's really useful for us and really show us how it has to be now.
The biggest takeaway for me was probably pacing. I think if we were to start this project over, we should try to be more on pace with each other, because at certain points, like part of the issue with the control arms where we had to redesign them is that I was at a certain point with the design where we were not necessarily all together. So there was some packaging issues that came about from that. And well, yeah, we would just try to keep a similar pace within all our systems.
I think for me, I think it would be that as well. I think we had a lot of issues with being at different levels in our subsystems, but I realized that there's really a whole deeper world when you concentrate on one specific thing, because I think I kind of understood the general side of cars in general, but now I have a deeper understanding more specifically of how gears work, how ratios work, and a lot of that is thanks to just digging in time into design and transfer case and having a class with Dr. Wu last semester.
I want to say something because you guys don't understand the challenges these guys have. Their car's not done, but financially, logistically, they have a lot of problems, and they've had a lot of problems. And we have worked tirelessly. I know Troy, he's here, and Joe, and Jenny and I mean, you don't know how many, I wouldn't call them fights, but arguments over budgets and time frames, and it's been a real challenge. But this is a very expensive project. To do this right, it's $25,000, $30,000 every year to do it right. And there are schools that spend way more than that. So being a small school, we work with a very tight donor budget. Thank you to one of our donors, time and money, sitting right here, Meineke. Sorry, I don't know. Bill Meineke here contributed financially as well as technically. And a lot of I know Troy has reached out. They have gone around scraping up money through GoFundMe, through donors. This is a really tough project. So to get it at least to where they are now, I think we owe them a huge congratulations, and I look forward to them finishing.
They deserve a lot of appreciation and encouragement as they go on. If you'd like to jump on and join the team, learn some skills, talk to them. They've got a whole list of things that you can help with. A couple things you can help me with. Again, if I can get the sign-in sheet, if you're in 102 or 107, and have not signed that in, check that before you go. If you're sitting in one of these wired chairs, we need to turn this room over for our poster session later. If you can help us by picking those up and putting them back on the rack, that'll help us a lot. Next session's at 2 o'clock down the hall in 202. And then we're back in here at 5 o'clock for our poster session. See you then. Thank you. Woo!
I think so. I told him the name of the channel, whatever. I'll probably post it after anyway.
Yeah, I know. I'll get this recording. Did we stop and see the recording?
Second time.